So today I will be discussing about Aerofoil lift and drag. So, as we know, almost all the any object moving through an airstream will be subject to some form of lift and drag. Okay, if you consider the case of automobiles, when it moves through an airstream, we will have mainly two effects. One is lift, which cause a tendency for the object to move upward, and on the other hand, the drag, which will slow down the body, giving a negative force in the opposite direction of motion. Okay, this is a symbol to effect that normally causes an object moving through an airstream. So up next is we are talking about angle of inclination. Okay, what is angle of inclination? Is simply the angle made by the object with the right inclined. Okay, angle made by object with the horizontal axis or surface of the surface on which the object is moving. Okay, I will show you later. So, greater the angle of inclination, smaller will be the upward lift component. The body will be having a force component of both lift and drag. So, what really happens is if the body is having a greater angle of inclination, the lift component will be smaller, or the drag component will be higher. Okay, so that's the effect when the angle of inclination is higher. Okay, so when the angle of inclination is smaller, okay, it will happen vice versa. The larger will be the uplift component and backward drag component will be smaller. Okay, I will show a diagram so you can understand easily. This is the figure of what I have just said. Okay, here is the reaction force on an inclined plate. So this is the plate down here. The direction of airflow will be in this direction. So what really happens is due to the airflow, the velocity will be higher. This is inclined surface, right? So the top part will be having more effect on the velocity of the airflow. So top part of the flat surface it will be having very high velocity. So by Bernoulli's principle, since the body at the top part is having high velocity, it will create this area of low pressure. On the other hand, on downward part will be having area of low velocity. So it will create a region of high pressure. So there is a pressure difference created between the top and bottom part of the body on a flat inclined surface due to the direction of airflow. Okay, there's a backward net effect due to the airflow on this flat body is, as I already told, lift and drag. There's a backward force which causes an effect on this body and as well as an upward force lift. Okay, so the actions or the forces that act on the a flat surface, flat body, inclined flat body placed on the path of a direction of airflow. Okay, airflow current. Okay, if you take a closer look, this is what will happen. The total reaction caused on the body will be split into two components. One is the lift force, and the other one is drag force. So this is the direction of airflow. Okay. So the angle of insulation or angle of attack is simply the angle made by this body with the horizontal. That is the angle of theta. Okay, this is the angle of theta. If I change this angle of theta, the component here also changes. It could vary. Sometimes the lift force component will be higher compared to drag force. Okay, that's what I told the first part. Okay, one is higher, one will be smaller. Only then we will get the net effective total reaction. Okay, so angle of inclination and angle of attack is simply the angle made by this flat body with the horizontal. Okay, so this is the case when it is having smaller angle of inclination. Okay, when the flat body is making. So these are the two cases. The first one is the smaller angle of inclination. This flat body is having a smaller angle of inclination. And the second case is a larger angle of inclination. Okay, when the body is having flat body is making a smaller angle of inclination with the horizontal, the lift component will be higher, while the drag component will be lower. On the other hand, when it is having larger angle of inclination, when the flat body is making a larger angle of inclination, the lift component will be smaller, while the drag component will be higher. Okay, these are the two cases that can happen with respect to the change in angle of inclination to a flat body placed in the air current. So this flat body have many differences, right? It can the component can change according to the angle which is placed. So we cannot have a stable platform or a stable part that could be placed in the place of a airstream. So you have to change it to a better structure. So we have to introduce the better form of instead of placing flat surface is aerofoil. Okay, so this is the aerodynamically accurate structure and to counteract both lift and the drag component. So let's look at how aerofoil is changed with respect to this flat body. So if the aerofoil profile is used instead of flat plate, the airstream over the top surface now has to move further faster than underneath air movement. Okay, that's the main specialty of using specialty aerofoil compared to flat plate. So this produces a greater pressure difference between the upper and lower surface and consequently greater really enhance the aerodynamic lift and promotes smooth airflow over the upper profile surface. Okay. So compared to the flat surface, aerofoil have a the main difference is it will enable the further faster than the underneath airman. Okay, fast movement. Okay, so main uh, effect or mean difference compared to flat surface. So it would really create a area of pressure difference compared to the bottom part and top part of the body. Okay, so this is a major difference between an inclined plate and inclined aerofoil. Okay, if I place the inclined plate on the direction of airflow, there is a turbulent flow over the upper surface of the air after coming in this direction to create an area of eddy. Okay, lot of eddies or a turbulent flow over the top surface compared to bottom. And the back part of the flat surface will be having an area of vortices. Because this is what happened when a flat inclined plate is placed in the direction of airflow. On the other hand, aerofoil, if I am placing aerofoil, which is a better aerodynamically accurate structure. Okay, same condition, there's direction of airflow in this direction. The aerofoil has specialty that the top bottom will be having a smooth flow or there's a smooth flow on the upper surface. Okay, top part this designed in such a way that it has a smooth flow. The top part will be having a smooth flow because on the top part will be having, you can see that it is having a very much smoother flow. So what really affect what brings down on that property is that it increased air speed and lower pressure. Okay, since this pitch is smooth on the upper part, the velocity will be very much higher in the top part. So according to Bernoulli's principle, when the velocity is higher, of course, the pressure will be lower. So due to increased airspeed, there will be an area of lower pressure compared to the bottom part. Bottom part will be having decreased airspeed and higher pressure. Okay, this is the basic actions or basic phenomena that happen in an aerofoil structure. This type of structure is known as aerofoil. So aerofoil always create a region of lower pressure on the bottom part, sorry, higher pressure on the lower part and lower pressure on the top part due to its structure. Okay, due to smooth structure on the top part will create a region of high velocity, so lower pressure. On the bottom part will create a region of lower velocity, so higher pressure. So obviously it will cause a higher the air movement will be from higher pressure to lower pressure, which will eventually cause the lift of this body. Okay, so the airfoil structure would promote the aerodynamic lift. Okay, this is all about aerofoil lift and drag. So this is a comparison between if I use a flat inclined surface and aerofoil structure in the presence or on the way of an air current. Okay, so this is a major drawbacks of flat plate and the effect that could be or the advantage that can be achieved by using aerofoil structure instead of flat plate. Okay.